Okay, this video is on geometric series. Now, we already talked about how this sequence here, 5, 20, 80, 320, and so on, is called a geometric sequence. And it's a geometric sequence because each succeeding term in the sequence is obtained by multiplying the previous term by what we call a constant ratio. So for this particular sequence, a sub 1, our first term, is 5, and our common ratio is 4. So we get each succeeding term by multiplying the previous term by 4. And we have also talked about how we can come up with a formula for each of the terms in the sequence. And we can come up with a recursive formula, which means a sub n, a particular term in the sequence, is just going to be a sub n minus 1 times r. That is, the previous term times the common ratio will get us the next term in the sequence. And that's called a recursive formula. We can also write an explicit formula. And the explicit formula looks like a sub 1, the first term of the sequence, multiplied times the common ratio to the power of n minus 1. So for this particular sequence, our formula would be a sub n minus 1 times 4. For this one, our explicit formula would be a sub 1, which is 5, times r, which is 4, to the power of n minus 1. Well, a geometric series is just the sum of the terms of a geometric sequence. So in that sense, it's very similar to an arithmetic series, except when we talk about a geometric series, it's the sum of the terms of a geometric sequence. So let's take a look at this example here having to do with a geometric series. It says at the beginning of each year, a person deposits $2,000 into an IRA that pays 6% interest per year, compounded annually. How much money is in the account at the beginning and the end of the first year? So at the beginning of the first year, that one's fairly easy. There's going to be $2,000 in the account, because at the beginning of the year, that's how much money we just put in it. At the end of that first year, we're going to have our $2,000 plus 6% interest. So 6% interest on $2,000 is going to be 2,000 times 0.06. Now I'm going to rewrite this, instead of writing it like that, I'm going to write it like 2,000 times 1.06. All right, I'm essentially just kind of taking these two numbers and putting them together. I'm going to write them in this form right here, 2,000 times 1.06, because that's going to turn out to be a little bit more convenient form for working with our next examples. So that's the amount of money at the beginning of the first year. This is the amount of money at the end of the first year. Okay, part B. How much money is in the account at the beginning of the second year? That is, after I've made my second deposit. So again, at the beginning of the first year, I have $2,000 in the account that I just put in. At the beginning of the second year, well, at the beginning of the second year, I'm going to put in another $2,000, but I'm also going to have in the account my original $2,000 along with all of the interest that original $2,000 accumulated. That is, I'm going to have all this money that was in the account at the end of the first year, $2,000 times 1.06. So here's how much money I have in the account at the beginning of the first year, and here's how much I have at the beginning of the second year. $2,000 plus my money from the beginning of the first year plus my interest. All right. Now, part C says, what's the total amount of money in the account after 5 deposits? Well, let's see. I'm going to use this notation here, B sub 1, just to indicate the amount of money after my first deposit, the balance after the first deposit. So after the first deposit, I've got $2,000. After my second deposit, that is at the beginning of my second year, I'm going to have, once again, my second deposit of $2,000 plus this original deposit times 1.06. At the beginning of my third year, I'm going to have my third deposit of $2,000 plus I'm going to have all of this money times 1.06. That is, I'm going to have all of this money along with the interest that it generated. So this amount of money is going to increase by 6%, and this amount of money is also going to increase by 6%. That is, I'm going to have 2,000 times 1.06, that's this amount of money, times 1.06 again, because this has stayed in there for another year. So instead of writing another times 1.06 out here, I'm just going to put 1.06 to the second power to indicate that I'm taking this amount and multiplying it times 1.06 again. Now at the beginning of my fourth year, I'm going to put another $2,000 in. So here's my fourth deposit of $2,000. Now all of this money is going to have earned 6% interest after having sat in the account for another year. So 2,000 plus this money is going to earn 6%, so that's times 1.06. This amount of money is also going to earn 6%, so that's going to be $2,000 times 1.06. And again, I'm going to multiply this times 1.06, so that's going to be to the second power. Then I've got this amount of money, which is also going to earn another 6% interest. So that's 2,000 times 1.06 squared times another 1.06. So that's going to be to the third power. Now finally, my last deposit here, my fifth deposit of $2,000. And once again, all of this money that was in my account here, it's going to have earned another 6% interest. So this is going to be $2,000 times 1.06. That's that money. This is going to be $2,000 times 1.06 squared. Then this amount of money, $2,000 times 1.06, see that squared times another 1.06 is going to make it to the third power, plus this amount of money, which is going to be $2,000 times 1.06 to the power of 4. And finally, I have this is my expression for the amount of money, the total amount of money after 5 deposits. And if I punch that into my calculator, then I would get $11,000, $11,274.19. All right. So in this example, we can see that if we wanted to, hopefully we can see there's kind of this pattern here. My fifth deposit, I'm going to have each one of these terms, and I keep multiplying them times 1.06 times another 1.06, and I stop with this term here, 2,000 times 1.06 to the power of 4. That is to the one less power than the number of deposits that I have. So what my formula is going to look like, it's going to look like the balance in my account after n deposits is going to look something like this. $2,000 plus 2,000 times 1.06 plus 2,000 times 1.06 squared. And then I'm going to keep adding terms, and then my last term is just going to be 2,000 times 1.06 to the power of n minus 1. So that would kind of be my general formula here for this particular account. Notice my first term is 2,000, And my common ratio, that is the number that I'm multiplying my first term by to get each succeeding term, my common ratio is 1.06. Well, just like before, where we found that we could come up with an explicit formula so that we didn't have to calculate each individual term in order to figure out how much money there would be in the account, I can come up with a formula for an explicit formula for this as well. And the amount of money in my account after in deposits, I can write as A sub 1 times R, my common ratio, to the power of n minus 1 divided by R minus 1. So this is the general formula for the sum of n terms of a geometric series. And in general, you write this formula as, instead of B sub n, you usually write it as S sub n because it's a sum. S sub n equals A sub 1 times R to the n minus 1 divided by R minus 1. And in fact, also, sometimes you see this formula written in a slightly different way. Sometimes you see it written like this. A sub 1 times, sometimes you see the 1 come first. 1 minus R to the nth power divided by 1 minus R. And either one of these formulas will work. So finally, let's take a look here at example number 2. It says, for the problem described in example number 1, use the formula for the partial sum of a geometric series to calculate the total amount of money in the account after 5 deposits. Well, this shouldn't be too hard because we already know how much money is going to be in the account. It's going to be $11,274.19. So we just want to see, does this formula give us that same amount of money? So I've got my formula here, S sub n. I can use either one of these. I think I'm going to use this one. S sub n equals A sub 1 R to the power of n minus 1 over R minus 1. So let's see, all I need to do is plug in my numbers here. Actually, let me write this as S sub 5 because I want to know the sum of the first 5 deposits. So S sub 5 equals, let's see, A sub 1, that's my first term, 2,000, times R, that's my common ratio, 1.06, to the power of n, and again, n is 5, so 1.06 to the power of 5 minus 1 divided by R, which is my common ratio, 1.06 minus 1. And if I take this and punch it into my calculator, then I would turn out to get $11,274.19. And notice, obviously, the appeal to this is that I can get this number without having to calculate all of those additional terms. That is, I've got an explicit formula for calculating the sum of some number of terms of a geometric series.